Have you ever imagined the universe as something still and unmoving? For most of human history, people believed the cosmos was fixed. But in the early 1900s, this idea was shattered forever. Astronomer Edwin Hubble made a discovery that changed everything. He noticed that light from distant galaxies was stretched, making it look more red. This redshift was the first clear sign that galaxies are moving away from us. The further a galaxy is, the faster it moves. This meant one thing: the universe itself is expanding. To picture this, imagine a loaf of raisin bread rising in the oven. As the dough expands, the raisins move away from each other, not because the raisins are moving, but because the dough between them is growing. In the same way, galaxies drift apart because space itself is stretching. This discovery opened the door to modern cosmology and helped us understand that we live in a dynamic, ever-changing universe. If the universe is expanding, you might think gravity would slowly pull everything back and slow the expansion down. But in the late 1990s, scientists studying distant exploding stars noticed something shocking. The universe wasn't slowing down, it was actually speeding up. This discovery surprised the entire scientific world. Something unknown was overpowering gravity and pushing galaxies apart faster and faster. Scientists named this mysterious force dark energy. We still don't know what dark energy truly is. It doesn't behave like anything we've ever observed. It fills all of space, and as space grows, dark energy grows with it. This strange force now makes up about 70% of the entire universe. Because of dark energy, the expansion of the universe is not just continuing, it's accelerating, stretching the cosmos at an increasing rate and shaping our ultimate future. With all this expansion, you might wonder, could the universe ever stop and reverse? Some older theories suggested the cosmos might one day collapse in a big crunch, shrinking back into a single point. Other ideas imagined a repeating cycle: expansion, collapse, and rebirth. But today's observations tell a different story. The data shows galaxies moving away faster and faster, not slower. The amount of matter in the universe, including stars, planets, and even dark matter, is not enough to counteract the push of dark energy. This means contraction is extremely unlikely with what we currently know. Instead, expansion appears to be the long-term trend. While scientists still explore cyclical or exotic models, the evidence strongly supports a universe that keeps growing, not one preparing to retreat. If the universe is expanding so quickly, what does that mean for what we can see? Light takes time to travel, and the universe has a speed limit. Nothing can move faster than light. Because of this, there is a boundary called the cosmic horizon, the farthest distance from which light has reached us since the Big Bang. As expansion accelerates, distant galaxies are pushed away so fast that their light will never reach Earth. Over billions of years, more and more galaxies will cross this cosmic horizon and disappear from view. This means that the observable universe, the part we can study, shrinks in a sense, even though the universe itself keeps growing. Future astronomers may see a much emptier sky, with only local galaxies remaining visible. So what does all this mean for us? We live inside a universe that is not static but constantly changing. The space around us stretches every second. Galaxies drift apart. Light travels across expanding distances. And dark energy shapes the fate of everything. This expanding cosmos also helps us understand our origins. If everything is moving apart today, it must have been closer together long ago, leading back to the Big Bangs. Our existence, our galaxy, and even the atoms in our bodies are part of this enormous cosmic story. As we explore the universe, we are really exploring our own place in it. The cosmic dance of expansion invites us to stay curious, keep learning, and remember that we are all part of something far bigger than we can imagine.